In this presentation, let's go on and look into the encryption. So before we know about the encryption mechanisms and the algorithms, so here are a couple of the basic terminologies that we need to know. Firstly, clear text. Clear text is also known as the plain text, which is an unencrypted readable text. Then we have the ciphertext. The encrypted text, which is formed after the encryption algorithms are run over a plain text, is called a ciphertext. Then you would have an encryption key. This is the key that is used to encrypt or to decrypt the data and is called the encryption key. So what exactly is the encryption? So it is the process of converting the data into a ciphertext that wouldn't be understood by any unauthorized person. So to decrypt the encrypted file, a person needs to have access to the secret key or the password that enables to decrypt it. The major use of encryption is to protect the sensitive information during the transmission and storage. So what are the key objectives of encryption? So the one would be the authentication. The origin of the message could be verified by the receiver. No other user would be able to send the message to the recipients as the legitimate sender. Next would be the data integrity. Once the message is received, the receiver can check whether the message was modified during the transmission or not. The next would be the non-repudiation, where the sender of the message under no circumstances would be able to deny that they sent the message. They did not send the message. So what are the primary uses of encryption? So the first would be protecting user credentials, then safeguarding the sensitive information, then it provides a secure channel to communicate, then it provides a higher level of trust during the file transfer, then it also assures the sender's identity. So what are the various different encryption types? We generally have three different encryption mechanisms. One is symmetric encryption, the next is asymmetric encryption, the third one would be hash function. So let's look into the symmetric encryption. So in this type of encryption, the sender and the receiver would have the same key for encryption and decryption. So as we can see in the diagram, the plain text gets encrypted using a symmetric key, and then the ciphertext, once it's formed, it could be again decrypted using the same cipher key. So let's talk about the asymmetric encryption. So in this, there is an involvement of two or more keys. So generally we would use two keys here. One is called the private key and the other is called the public key. So the public key here is used to encrypt the messages, and the private key is used for the decryption of the messages. So let's talk about the hash function. So here it's basically the one-way encryption. So it cannot be reversed in the other way. So let's say the input is Fox. It is run through an algorithm, a hash function, and is converted into a hash sum. So on the second line we could see that the sentence, which is the red fox runs across the ice, is again run through the hash function, and we would get a hash sum. So similarly, this hash sum could not be reversed back to the actual plain text. So digital signature. So digital signatures usually implement the asymmetric encryption in order to simulate the security properties of a signature in digital, instead of using the written format. There are two keys involved in this process, a private key for signing the messages and a public key for verifying the signatures. The digital signatures are mostly used in the electronic signatures implementation. So working of the digital signature. So the hashing algorithm basically creates a hash value. to which the sender's private key could be used for signing the message. Once the message is signed, the signed message could be sent out to the receiver, and that could be rechecked using the sender's public key. So this is how the digital signature generally works. So the summary. So encryption in general is the process of converting the data into a ciphered data. Symmetric encryption uses just a single key for both encryption and decryption. And asymmetric encryption uses two or multiple keys for encryption and decryption, known as private keys and public keys. A hashing function is a one-way encryption method where a cipher data cannot be reversed back to its actual form. A digital signature is an implementation of the asymmetric cryptography.